What is a fluid? A liquid? A gas? A solid? We generally define fluids as something that flows. Now, most of the time when you think about a fluid, you think about liquids. But a gas, it turns out, can also be a fluid as well. Let's take a look at the differences between these two. When we look at gas molecules, we can see that they move freely throughout space. They generally don't interact with each other except for occasional collisions with each other or the walls, as you can see in the top figure here. One of the main differences is that gas is compressible. And this is due to the fact that the molecules are so far apart, there's lots of room for them to be squished closer together. Meaning that you can take a volume of air and squish it into a smaller volume. The mass of the molecules stays the same. You have the same number of molecules. You just have those molecules in a smaller space. Now, when we take a look at liquids, molecules in liquids are weakly bound to each other and stay pretty close. These weak bonds do allow the molecules to move around, however, and that's why liquids take the shape of whatever container they're in. Gases do this as well, but liquids do it in a more obvious manner. However, liquids are not compressible because the molecules are already as close together as they can get. Solids, on the other hand, have molecules that are more strongly bound and are not generally allowed to move around. So they have a much more structure to them, which is why we call them solids. Now, as we move forward into this chapter, we need to talk about some properties that you've probably heard before, but we'll review. The first is going to be volume. So volume is the amount of space that something occupies. So we can go through and calculate the volume of something by looking at the 3 dimensions that make up that particular space. So in this example, I have a cube. Each side of this cube is 1 meter long. So if I want to know the volume of this cube, I'll multiply the width, 1 meter, by the height, 1 meter, by the depth, 1 meter, which gives me 1 meter cubed. Now, 1 meter is the same thing as 100 centimeters, so I could do the same thing with the centimeters. The volume of this cube is 100 centimeters times 100 centimeters times 100 centimeters, which if you multiply that together, you'll get 1 times 10 to the 6 centimeters cubed. Now, these two volumes are the same, so we need to know how to convert back and forth between them. The SI unit for volume is meters cubed, so you do need to know how to convert back and forth between them. So if we take our 1 meters cubed volume, and we know the difference, there are 100 centimeters in 1 meter, so I can create my conversion factor. But because I have meters cubed, I need to cube my conversion factor. And if I do that, then that means basically I'm doing 100 centimeters times 100 centimeters times 100 centimeters. So that'll get me my 10 to the 6 or 1 million centimeters cubed that I had before. So again, the SI units of volume are meters cubed. And so you may see some other volumes. Just make sure that you do that calculation for each of the dimensions when you're doing your unit conversions. You may also see milliliters used. 1 milliliter is a volume measurement, and that's equal to 1 centimeter cubed. That's a common volume unit that you'll run into. So make sure you write down that conversion somewhere. Now next, we need to talk about density. And we're going to specifically talk about mass density. Most of the time when you hear the term density, they are referring to mass density, but there are actually different types of densities as well, and you'll learn more about that next semester. So mass density is how much stuff is in a volume. It's a ratio of the mass to the volume, and we write density with the Greek letter rho, which you can see in this table here. The SI units are kilogram per meter cubed. So if you show up with something else, you'll need to convert to kilogram meter cubed. And density is mass over volume. It is independent of the object's size. It's actually a property of the material itself. So a chunk of mercury is going to have the same density as half the chunk of mercury. So mass can change depending on how much of something you have, whether you have a big chunk or a small chunk. The density of that is going to stay the same, with the exception of gases. Since gases are compressible, their density can be changed. So when we talk about the density, if you look at the top of this table here, it says that it's at a standard pressure and a standard temperature. And we'll use these values in this table quite often moving forward. Again, the SI unit is kilogram over meters cubed. You may also run into grams per centimeters cubed. So you'll need to convert both of those, grams to kilograms and centimeters cubed to meters cubed, in order to convert it properly to be able to be used in your calculations. All right, let's go through and do an example. What is the mass of air in a living room with dimensions 4 meters by 6 meters by 2.5 meters? And first, we'll start with calculating the volume. So the volume, again, is just each of those 3 dimensions multiplied together. So 4 meters times 6 meters times 2.5 meters gives me a volume of 60 meters cubed. Now, in order to figure out the mass, I can remember that my density is equal to mass over volume. We've already calculated the volume, and we can look up the density from our table here on the right. So in order to find mass, I do a little algebra, and my mass is going to be equal to the density times the volume. So the density of air is listed there as 1.29 kilogram per meters cubed. I'll multiply that by my 60 meters cubed that I calculated just a moment ago. You'll notice that my meters cubed cancel, leaving me with kilograms. It's always a good sign that I've done things properly, that I get the units that I would expect, mass units. And the result is 77 kilograms.